In this video, we're going to derive the law of sines. I've got drawn here a generic non-right triangle, a triangle that doesn't have any angle that's labeled as being 90 degrees. And we'll start by drawing what's called a height, which is a line segment from one of the angles down to the opposite side, and we want this line segment to be perpendicular to the opposite side, and so we should draw a little box here to denote that the angle is 90 degrees. And we'll label this H for height. Now, we don't know the length of this height, and it's not even a component labeled on the triangle, so it's a kind of a temporary placeholder for us, and the purpose of it, the reason that we want to draw that line H, is because now we can see two distinct right triangles. One on the left that involves angle A. I'll highlight that here in red. So this is a right triangle. And there's one here on the right that's got angle B in it. And I'll highlight that one in blue. Okay, and both of these right triangles involve side length h. They both have a side length h. Now what we can do is apply the sine function to both of these triangles. So I'll start with the red triangle, and we'll work on the sine of angle A. Let's find an expression for the sine of angle A. Well, we know the sine of an angle in a triangle is the opposite side length divided by the hypotenuse. And the side opposite angle A is the side H, and the hypotenuse of the triangle is side B. So we can express the sine of angle A as the opposite side H divided by the hypotenuse, which is B. And we can also go ahead and look at the blue triangle and write a similar expression about angle B. So if we were to stand at angle B, the opposite side is H, and the hypotenuse is this side A. So opposite over hypotenuse, the sine of angle B is H over A. Now both of these statements here, both of these equations involve side length h. Right? They both have an h in them. And so what we can do here is solve for h. So if I were to multiply on the left equation both sides of the equation by b, I can cancel it on the left and isolate h. H. So h will equal b sine a. And similarly, in the blue triangle, I can solve for h by multiplying both sides by a. If I multiply it by a on the right side, it'll cancel and isolate h. And we see that h equals a sine b. Okay, so now we have two distinct equations that define a side length h. So we know that this side length h must be equal to this side length h because they're both the same side length. And on the left, we used the right triangle to find that h equaled b sine a. So we could substitute b sine a for h on the left. And we can now set that equal to what we learned about the blue triangle, which was that h equaled a sine b. And we could substitute for h over here with a sine b. Now we're almost done. There's just this one last step to kind of tidy things up to form the law of sines. What people typically do is divide both sides by b to bring side length b over to the right underneath the angle b, and by doing that you'll cancel side length b from the left side. And then what we'll also do is we'll try to bring side length a over to the left under angle a. So if I divide both sides by a, I can cancel it on the left and end up with the equation sine of A over A equals sine of B over B. And this is what's known as the law of sines.